Today we will go over the product law of exponents. We will simplify a monomial using the multiplication law of exponents. So as you can see right here, by the definition of monomial, meaning one term, we're only going to be dealing with one term and a bunch of different ways that it can look and how we can simplify that to the easiest form to deal with. First, understanding the rules. When multiplying terms with like bases, you multiply the coefficients and add the exponents of like bases. Now, this is the first time for my class that I am explaining that the variable in the situation is named the base. It's simply the value that is being multiplied when we're dealing with an exponent. The coefficient is still the number that is multiplied to our variable or variables. And then our exponent is the value, or I'm sorry, the number of times we multiply our base by itself. So for example, down here, our coefficient is 3. When we're dealing with exponents, it only affects that base. So this 3x to the power of 4, the coefficient is not affected by the exponent. It is still by itself. X, however, in a non-simplified form, would be x times itself, a total of 4 times. Now the rule behind this is adding the exponents. If you do not see an exponent on a value, that means the exponent in that situation is 1. X to the power of 1, x to the power of 1, so on and so forth. We can add all of those together to equal 4, which it comes to our main example. Whenever we are multiplying like bases, we can simply add their exponent. So for this example, simplify each expression by expanding numerator and denominator. The numbers that we would add, since these are like base terms, is 2 and 7. We will still have the same variable base, n, but now we'll add 2 plus 7, which gives us an exponent of 9. So n squared times n to the power of 7 is now n to the power of 9. When parentheses are introduced, we still multiply across everything because there is no addition or subtraction that is separating the terms. There is no subtraction or positive in between the parentheses. So this is a monomial. In this case, we multiply everything coefficient-wise like normal. We can multiply the 2 times the 8 to get 16. Our variable, the only one we have, is a, so we can multiply that together. A squared times a to the power of 1 means I would add 2 and the 1 exponent, which would give me a to the power of 3. So my monomial simplified is 16a cubed, or 16a to the power of 3. Some more examples. We've already covered the first two. We add the 2 and the 7, which gave me an exponent of 9. We multiply coefficients whenever we have them. We treat that like the basic math that we've been doing for years. And our exponent is what is new. Knowing that that is the 1, we have a squared times a to the power of 1. Adding the exponents gives me a to the power of 3. So that's just the example we already did. Along with that, when we have 3 sets of parentheses, we can add all the exponents together, or to keep it simple, mark down everything for exponents. Start with the coefficients. My coefficients is -5, 4, and 1. So I have -5 times 4 is -20, times 1 is still -20. When multiplying my x terms, I'm simply adding the exponents. X to the power of 1 times x to the power of 2 becomes x cubed, or x to the power of 3. Our y to the power of 1 times y to the power of 4. Add the exponents together, and we get y to the power of 5. This is showing us the dot product, showing that we're multiplying. Make sure you know all of your exponents. I have x to the power of 1, to the power of 2, and to the power of 4. So I'm still going to have the base of x, and the exponent is 1 plus 2 plus 4. So 1 plus 2 is 3, plus 4 is 7. So we have x to the power of 7. Remember that coefficients are just multiplying the number together. A -4 times -5 is a positive 20. We have the base of x being multiplied, so we know we're going to have a base of x. Adding the exponents together gives us 3 plus 7, which is 10. So my monomial simplified is 20x to the power of 10. My last example. I can tell that everything is being multiplied, even though there is a negative in the equation. It is still all multiplied one term. So I multiply the coefficients. -3 times 2, which is a -6. I can look at the base variable j and add its exponents. 2 and, remembering that there is a 1 there, gives me 3. And then my base variable k. Our exponents are 4 and 6 for the base k. 4 plus 6 is 10. So my final simplified monomial is -6 j cubed k to the power of 10. Now remember, when we are multiplying, we have one monomial. We can combine like bases by adding the exponents together. Going back up here where I wrote out x times itself 4 times, that'd be 1 plus 1 plus 1 plus 1, which gives me the original of x to the power of 4.